So we're moving into a whole different chapter, and we're skipping a couple chapters. I think the last thing we did was chapter 11, right? Now we're on chapter 15.1, 15.2, 15.3. We will be going over 15.1. But 15.1 is pretty easy. And well, last week of class, I kind of want to do a little bit easier stuff. So let's get through this first, and then we'll move on to 15.1 where things get a little bit nicer. Okay. So we're starting chapter 15. Chapter 15 is called non-parametric statistics. So non-parametric statistics. Okay. So why don't we just talk about what this word means first, and then we'll move into actually doing the tests that we do for this. Okay. Parametric. Well, seems to me that the word parameter might be in there. Parametric, parameter is kind of hidden in that word. Let me write that on the side. So you got the word parameter. What do you guys remember about things called parameters? Kind of reaching back a little bit. Yeah.
There's like a certain boundary. I don't know.
I kind of see what you mean by that. So in general, that might be what a parameter might be.
Like between point A and point B.
Yeah, okay, I can see how that is. We actually had like a different definition for that, but that's fine.
I don't know.
No, it's been a while since we talked about that, but that's a good guess. Remember when we talked about how parameters described a certain type of thing? We had parameters and we had statistics, right? Statistics measured a sample, while a parameter measured what's the opposite of a sample? A population. Good. So Bobby's guess is fine, but what we defined was that parameters described a population. Okay, so when we're talking about non-parametric statistics, we're talking about statistics that don't have anything to do with things about the population, right? Not the population. Okay. Now, let me tell you an opposite of non-parametric statistics. The opposite is parametric statistics, right? Okay, I just took the prefix non off, and now we have the opposite. Okay, I'm going to tell you that we've been doing parametric statistics the whole time that we've been doing all these different types of tests. Everything that we've done so far has been parametric because there was something about the population that we needed to know to do these questions. The thing we needed to know about the population was that one weird assumption that we did every single question. We checked that the population was bigger than 30 or the population was normal. When I say population, I mean sample size bigger than 30 or the population being normal. We had to check those assumptions every single question that we went through. And it was kind of annoying, but after a while, it kind of got a little bit better, right? Okay. In non-parametric statistics, we don't have that assumption. So we don't need that to happen, okay? We don't need n bigger than 30 or the population being normal. Okay, so no assumptions needed here. You can do this for any sort of question, no matter what the population looks like, no matter how big of a sample that we have. Okay. Now, since we have non-parametric statistics, we have a couple tests to use for this. I think the big question is, well, why can't we just use non-parametric statistics for every single question instead of having these weird parametric statistics, right? That seems like a lot of tests to have in our mind. Why can't we just use non-parametric statistics for everything? And the reason for this is because there's a big con for non-parametric statistics, okay? These tests are basically not that good, okay? They kind of suck, okay? These tests work a lot less as well as these the parametric test that we've learned about before. Everything we've learned about before has been a little bit better than what we're gonna learn now, okay? But if there is no choice and we have a very small sample size, we don't have a normal population or we don't know it's normal, that's when we turn to non-parametric tests, okay? So this is what we're gonna learn about. We'll learn about stuff where the population is not normal and we have a small sample size. Okay. First thing we're gonna work with are two sample hypothesis tests. Let's try to remember what these are. I guess we have two samples, right? Not just one. And since we have hypothesis testing, we're doing that thing where we come up with the null hypothesis, alternate hypothesis, find the p-value and figure out what our conclusion is, right? Okay. Since we have two sample sizes, we have two samples, there's two different types of ways that this can be done. Independent and paired, right? What's the difference between independent and paired?
Independent doesn't influence, or like one doesn't influence another.
Awesome, right? Independent samples, one observation doesn't influence an observation in the other sample. Paired samples can kind of be like paired together. So every observation in sample one can be paired with another observation in sample two. Kind of like when we have, I don't know, like before and after, stuff like that. Okay. So what I'm gonna do, I'm going to give you the Minitab command for two sample hypothesis tests, non-parametric, when we have independent versus paired. Okay. When we have independent samples, the test we're going to use is called the Wilcoxon's rank sum test. Okay. But in my mind, I kind of like just memorizing the Minitab command. Okay. Minitab command for this is going to be the Mann-Whitney test. Okay. So in this section where we have non-parametric samples, we have independent samples, and we're trying to do a hypothesis test, we're going to use the Mann-Whitney test. Okay. Next, if we have paired samples, technically it's called the Wilcoxon's signed rank test, but on Minitab, it's actually called the one sample Wilcoxon test. Okay. So two different Minitab commands. You don't really have to know the name of the actual test, but you do have to know the Minitab command since that's what you're going to be looking for. Okay. All right. Let's go on to the next page. Okay. There's one more difference between parametric and non-parametric tests. They have different definitions. We use different Minitab tests, and we're actually going to use it for a different symbol. Okay, so the symbol we're going to be centering around isn't going to be what we've been dealing with before. Okay, now before, I think we've always been talking about the population mean, right? Everything in our conclusion has mu. Even our like null and alternate hypothesis use the symbol mu. Okay, in these tests, we're actually going to be focusing on the population median, not the population mean. Okay. So, just a refresher, what does the median represent? Middle, right? It's the middle. Remember, if you're driving on the road and there's like a median strip to your left or to your right, that represents the middle of the road, right? So median represents the middle. Okay, and let me just give you some notation. We haven't talked about a symbol that represents the median yet. Okay, we do have population mean. Remember, we used mu for that. The median is going to use this symbol, M. Okay, so if you ever wondered why population mean uses mu like a Greek symbol, it's because M was already taken by the median. Okay. One thing I want you to note on here is on the final exam, I don't write the final exam. A bunch of the math faculty writes it themselves. Sometimes they'll use this symbol. It looks like an N, but it's like a Greek letter N. Okay. For my class, since like WebAssign kind of uses this, and also Connect Math and Minitab uses this. I'm gonna use this symbol. If you're looking at the final exam, like next week, for example, if you see this symbol, this is the population median. That's all it means. Okay. All right. Of course, if we have two samples, we could use mu1, mu2 to represent the population mean. If we have two samples in our examples here, we can have M1, M2 represent the population median. Okay. All right. Any questions so far? Okay. Let's flip our page a little bit. Oh no, I did not plan this out. We rotate. There we go. Okay. So our next page, if you remember from a couple classes back, we came up with a little flow chart where we took one sample, two samples, and we talked about when we're supposed to use each of the Minitab tests. I think this is the easiest way to organize your thoughts here, okay? One of the things we talked about was sometimes we talked about the assumptions and it seemed like that didn't really belong on the chart since it didn't really determine like if we were going somewhere or somewhere else on the chart. This is why we do the chart, okay? This is why we have the assumptions on here, okay? Because parametric and non-parametric depends on if we have a large sample with the population normal or a smaller sample and no mention of the normal population, okay? So, of course, we talked about what we have when we have one sample, and we had the one sample z-test, one sample t-test. I'm going to add two more things here, okay? First of all, if we have two samples that are independent, and we have that non-parametric sort of thing going on. We have something less than 30, no mention of normal population in the question. Any guesses on what should go here based on our notes from the last page? Non-parametric, but what was the Minitab command? Yeah. Oh.
Mann-Whitney.
Yes, the Mann-Whitney test. Remember Mann-Whitney for independent, and I think it was one sample Wilcoxon for the paired samples. Okay, so let's write that in. Mann-Whitney. And of course, that leaves the last one to be the one sample Wilcoxon. Okay. So now what we have is we have a nice chart. It's getting a little bit bigger, but we have all the Minitab commands on the right of what we would choose. And now we have two extra things. If we have a small sample, no mention of normal, which means we have a non-parametric test, we can either do the Mann-Whitney test or the one sample Wilcoxon test. Okay. Any questions so far? All right. All right, let's take a look at what we're gonna do if we see some of these, okay? I know it looks like a lot of steps. I promise you it's pretty much the same thing as what we've been doing before, okay? So step one. First, we're going to state our assumptions. First thing we're gonna look for is, do we have independent or paired samples? Okay, that's gonna depend, that's gonna tell us which test to use, right? Once we talked about that assumption, we're gonna take a look and see if the assumptions are not met, which means the sample size is either really small, like less than 30, right? And there's nothing in the question that talks about a normal population, okay? The thing with these tests, for non-parametric tests, you have to check both of them, right? We have to have small sample sizes and the population being not normal. So you have to write both of them down, okay? Step two. We're going to state the null and alternate hypotheses. For these, it's basically going to be the same as what we've been doing before with two sample tests, except instead of using mu, we're going to use m. Okay, since we're talking about m. Okay. Step three, we're going to be given the significance level alpha, and the confidence level formula is the same as we've always been dealing with. Okay. Step number four. We're always going to be given the raw data values for these. So we're always going to be given data values. We're going to type them into C1 and type them into C2. Okay. Next, if we have independent samples, of course, we're going to use Mann-Whitney. We'll click a bunch of steps, and I think it'll make more sense when we do an actual example. This is what we'll do, okay? Paired samples, there's a little bit more work. And what I'm gonna tell you for this is I'm not gonna give you a question on paired samples where you have to like use Minitab 4, okay? I'll show you what to click. I can guarantee you that the final exam and my exams will not ask you to type this into Minitab, okay? You do have to know what it is, but you don't have to know how to type it in. So don't have to know Minitab like clicks for paired. Okay, I'll show you how to do it. I think it's a little bit more complicated. There's a lot of different things you have to do. Therefore, I'll show you. You don't have to reproduce it. Okay. Step 5, same thing. If P is less than alpha, reject. P bigger than alpha, fail to reject. And step 6, we're always going to write a conclusion the same way as we've always done it. Not enough evidence, we conclude and end with the alternate hypothesis. Okay. Any questions before we do an example? All right. So here's an example. We have 14 students. They're in the statistics class online. And we have another sample of 12 students who took another class in a traditional classroom. Okay. Both classes were given the same final exam, and we're going to see if there's a difference between the median scores of the two classes. Okay. We're going to use 0.05 level of significance. Okay. So before we do the question, let's just write our information down. Okay. Not much to write down, but I do like to write down what my sample means, or what my sample actually means. So sample 1, let's make sample number 1 online because, well, it came first. And I'll make sample 2 traditional. Okay. What's the sample size of the online class? Kind of hard to count. 14. Oh, it actually said in the question. Nice, 14. What about sample size of the second sample? 12. Good. All right. So pretty much all my information is written down. Let's just check in. Do we have independent or paired samples? Independent. Why is it independent?
Because they don't have it, their data have nothing to do with each other, their own values.
Yeah, right. Their data values, I mean, students in this class aren't gonna have any effect on students in the other class. You can also see, like, if you tried to pair up every single observation, it would work until like you hit 97, and 97 wouldn't have anything to pair with, so can't really pair them up either. Okay, so therefore, we definitely have independent samples. Okay. Let me skip the Minitab question real quick, and we'll go to step 1. After we go to step 1, we'll swing on back. Okay. So I said we had independent samples. That was one of our assumptions. Okay. Our second assumption was we have to look and see if the sample sizes are less than 30 now, right? So we have 14, we have 12. Are both of them less than 30? Good. So this is actually a good thing for us now. Okay, both of them are less than 30. And let me think about this. Okay, yes, even though we checked this, we're good, but we're not done yet. We have to go back in the question and see if there's anything about a normal distribution. Anything about normal in here? No, right? There's no mention of a normal population here. So nothing in the question about a normal population. Okay, so once we checked those two observations, we're like, cool, we've satisfied the assumptions, okay? At this point in the question, I'm pretty sure you can like know by the definition of non-parametric statistics that we have a non-parametric question. We're either going to use the Mann-Whitney test or the one sample Wilcoxon test. There's actually another hint in the question that told me that this was non-parametric, which means this chapter, okay? If we go back here, in the very almost last question, we wanted to see if there was a difference between the two median scores. Okay, the word median here is very important because it gives me the hint that I'm not dealing with the population mean anymore. Okay, remember, all our other tests talked about the population mean. The last couple of tests that really about deal with the population median. This gives us a good hint that we're either using, well, Mann-Whitney test or one sample Wilcoxon test. Okay, since we have independent samples, are we using Mann-Whitney or one sample Wilcoxon? Mann-Whitney, good. So up here, I'll write that we're using the Mann-Whitney test. Okay, so we got Mann-Whitney. Before we go and actually do the test, we also have to write our null and alternate hypotheses, okay? Null hypothesis has an H0, alternate has an H1, okay? And we're not talking about the population mean anymore, we're talking about the population median. What symbol are we using for median? Yes, M. So M1, M2, right? Okay, remember, null hypothesis, always use an equal sign. Doesn't matter what type of question we're working on here, okay? Alternate hypothesis looks very similar to the null hypothesis, but we're gonna have a different symbol. Take a look at the question. What symbol do you think we should have between M1 and M2? That's not equal, right? Because the question said, is there a difference between the two medians? That gives us the hint that this is a not equal to question, not bigger than or less than. So let's use not equal to. Okay. Before we get to Minitab, we also have to work with the significance level, right? So remember, significance level alpha is 0.05, right? Okay, confidence level always has that same formula, right? 100 times 1 minus alpha. Okay, so all we have to do is just plug in, right? 100 times 1 minus 0.05. Okay, I know a lot of you like to speed through this, but for some reason my brain does not understand multiplication and addition very well. So I actually have to subtract them. I get 0.95 when I do the subtraction. Finally, when I multiply by 100, I get 95. Okay. Any questions on the significance or confidence level? Cool. Okay. Next, what we're going to do is we're going to type stuff into Minitab. Okay. So here's what I'm going to do. I don't have Minitab open on my computer right now, so let me do that. Right. Here we go. Okay. Okay, and bear with me because I completely forgot to actually type in the data values when I got in class today. So let me go ahead and do that. Looks like everything's typed into Minitab. Okay, what I'm gonna do is if you ever get confused with what to type, you could always go back to the steps on the 3rd page of the notes, okay? So I'm just gonna follow the steps under independent samples. I'm going to click on stat. We're not going to basic statistics anymore. We're actually going to go all the way down to non-parametrics. So a whole different section of stuff to click. Once we finish doing that, we're going to click on Mann-Whitney. Okay. And a lot of this is kind of self-explanatory. Okay. We're going to click C1 for the first sample. We're going to click C2 for the second sample. We're going to type in the confidence level that we got in step number 3, 95. Okay, and under alternative, we have a few options. Whatever the symbol we use in our alternative hypothesis goes here. So since we did not equal, let's do not equal, okay? Once we do that, we're going to hit OK. Okay. All right, so once we do this, we are going to scroll all the way down to where it says test, and it'll give us not just one, but two p-values, okay? Let me give some more decimal places so you can see if there's anything different. Probably not, okay? These two p-values are different from each other, okay? One of them says not adjusted for ties, the other one says adjusted for ties. I'm just going to tell you that the difference doesn't really matter for this class, okay? Basically what it's doing is they're like subtracting the two and seeing if there's anything tied. Don't worry about that. All we're going to do is focus on the adjusted for ties p-value, okay? So we're just going to focus on this guy right here that says 0.83689. Okay. Any questions on this one? Okay, one other thing that can happen with the Mann-Whitney test is it might just give you one p-value, okay? Don't worry about it. If it gives you one p-value, just use that one. If there's two of them, use the one that says adjusted for ties, okay? I promise you, it doesn't really matter. Whatever p-value you get is fine. Okay, so basically what I have is I have our, what we typed in the mini tab. We have our p-value, and the p-value that we're going to use is the 0.71868. The one on the bottom that says adjusted for ties. Okay. Once we found our p-value, pretty much everything stays like the same as what we've been doing before. Okay. Remember, to reject or fail to reject, we have to compare p to which value? Alpha, good. P is 0.71868. Alpha is 0.05. Which one's bigger, P or alpha? P, good. And since P is bigger, do we fail to reject or reject? Fail to reject, good. Fail to reject the null hypothesis. Okay. And since we fail to reject the null hypothesis, are we going to start with we conclude or not enough evidence? Not enough evidence, right? So we're going to start a sentence with there is not enough evidence to conclude that. Okay, so that's part one of our sentence. What's the second part of our sentence? Alternate hypothesis. Remember that said M1 not equal to M2. Okay, that's all we do for these types of questions. Any question on example number one? Okay, it's not that bad, right? It's just a few differences between like what we did before, what we're doing now. I don't think it's too bad. I think the hardest part is determining which test to use, which we will do some practice on later. But let's go to a different example first. Okay, so here we have a group of 8 individuals. They have high cholesterol and they participated in an exercise program to lower their cholesterol, okay? They were measured before and after exercise for each individual. They have the results down below. We want to see if the median cholesterol level after treatment is different from the median before treatment. Okay. The big hint in this question is the word median, right? Since we are talking about the median, we know that we're looking for either the Mann-Whitney test or the one sample Wilcoxon test, 2 non-parametric tests. Okay. What I'm gonna do, I think what I'm gonna do, I'm gonna give you a few minutes to work on this. I know we haven't talked about the one sample Wilcoxon test. Yeah, sorry, I'm saying the wrong thing. Okay, try this out on your own, even though we haven't really gotten to Minitab yet. But I think we'll be able to get this done by the end of class. All right, let's come back together here. I walked around, I saw some awesome answers, so I think we're getting this one pretty good. So before we did the question, what I would do, I would never like require you to write this on like a test or anything. But I kind of like to write down what my samples are, because I have two samples. I got sample number 1. I've got sample number 2. Oh my gosh. And maybe sample 1 means before, sample 2 means after. I don't know. The before one came first. The after one came second. Okay. And sometimes I just go in and write how big my samples are too. So N1 in this case was 1, 2, 3, 4, 5, 6, 7, 8 things, right? Same thing for N2. Okay. This is what I would write down for some sort of question like this. Okay. Checking in, did we have independent or paired samples here? Paired, and why were they paired? Exactly, right? So two big hints that gave me an idea that we have paired samples. One was we have a before and after sort of thing that kind of gives it away. Actually, 3 things. 2, we have the same sample size, which is a big hint that we can pair them together. And 3, well, looks like you can kind of pair each of them together, which is a good hint for me. All right, so we definitely have paired samples. So which Minitab test did you guys think? Yeah.
1 sample Wilcoxon.
Awesome. 1 sample Wilcoxon test. Okay. So paired samples, 1 sample Wilcoxon test. Let's check our assumptions, make sure that we have non-parametric stuff. The first assumption is that we have paired samples, which we kind of already talked about before, but I'll write it down anyway. Okay. Second thing, we have to check a bunch of things. First of all, we have to check if the sample sizes are less than 30. Are they less than 30 here? Yeah, right. 8 is definitely less than 30. So both sample sizes are less than 30. And was there anything about a normal population in the question? No, right? Nothing about a normal. No mention of a normal population. Which is actually good in our case, right? Okay. Once we did that, can someone tell me what their null hypothesis was? Yeah.
And 1 is not equal to them.
That was your alternate hypothesis, but good. One step ahead of me. No, I'll write that one down. Yeah, and your null hypothesis was the equal one.
Yeah.
Cool. 2 steps ahead of me. That's good. No, you're totally fine. All right. Oh, yeah.
I thought the ultimate was N1 greater than N2 because it's the question says that after it's supposed to be lower than before.
Oh, let's see. A group of 8 individuals with high, I write these very fast, so let's see. Group of 8 individuals participated to see if it lowered cholesterol levels. Huh, that's actually kind of, yeah, I can kind of see that. I can kind of see that too. And then it says different here. So if you said not equal to, that I actually thought that was true too, so don't worry. Usually the last sentence and everything in the front should match. I wrote this question a little bit weird. Yeah, why don't we go with the lower thing? Because I think that makes sense too. That's really smart, thanks. Okay, let's see. If it lowers cholesterol level, should it be a greater than sign, a less than sign, or a not equal to sign?
I
Yeah, greater than, because if we're lowering it, then before should be higher than after. Okay, nice. So if let's do this. If you said not equal to, fine. It also could be greater than, depending on how you read the question. I should pay more attention when I write up these questions, but nice job there. All right. Any other questions on step number 2? All right. Step number 3, the significance level for this question was 0.05. What did we get for the confidence level? 95. Okay, if you want to see the work for this, the last question had the same significance level. So the work for this, I'm going to be lazy. Example 1 did this. Okay. Okay, step 4, I'll show you Minitab after this. Let's just go through how we interpret this. Our p-value definitely seems to be 0.484, right? Okay. And whenever I decide if I reject or fail to reject, I write the p-value, the alpha value right next to each other. Which one was bigger, P or alpha? P, did you reject or fail to reject? Fail to reject. Okay, and our conclusion started with, yes, there is not enough evidence to conclude that, and we always end with the alternate hypothesis, right? Which said either M1 was not equal to M2 or M1 was greater than M2. Okay. So this is what I am going to do, okay? I'm going to show you how to do the Minitab for this, but I promise you it's a little complicated, so I'm not going to test you on the Minitab, okay? But let me just quickly show you on what you would do here, okay? So we've got all our stuff typed up, which I probably should have done when you were actually doing this. Okay, basically what you're gonna do is, I know the steps kind of outline it in the question, but it doesn't really like kind of explain what exactly is going on. So what we're gonna do is we're going to click calculator, okay? We're going to store the result in variable, and this is just telling us to type in a column. So maybe I want things in column 3. Okay, so it's gonna type a bunch of stuff into column number 3. Okay, and what we're gonna type into this box, or what's gonna go into column 3, is column 2 minus column 1. Okay, that's what we're typing in to column 3. Okay, once we do that, we're going to click OK. Okay, so basically what we've done is we've just stored column 2 minus column 1 into column 3 for every single row. Okay, once we do that, we're going to click Stat, Non-Parametrics, and One Sample Wilcoxon. Okay, we're going to select C3 in our variables box. This is our combination of C1 and C2 where we subtracted them. Okay, once we've done that, we're actually going to click the test median box. Okay, and we're going to keep this as 0. Don't really worry about what this means, but we're just going to keep that as 0. And we're going to type in the alternate hypothesis here. Okay, I know we said it could be greater than, just for consistency, I'll just make it not equal to, since that's kind of what I was thinking in the beginning. Okay, so whatever alternative hypothesis, we'll leave it as that. I'll click OK. And this is how we got that p-value of 0.484. Hopefully that matches up to what I had before. Let's see. Yep, cool. All right. Any questions on the Minitab for this question? All right. Okay, this will not be on the test on Friday, but this is game for the final exam. Okay, so Wednesday we'll do some review for the test on Friday, and I will see you on Wednesday.